Hi, Assalamualaikum to all my panel. First, I will introduce myself. My name is Muhammad NAJHAN bin SAMPRAN and my supervisor is Dr. Muhammad Sanusi bin Abdul Aziz. And today, I will present to you about my final year project, and the title is The Effect of MQL Nozzle Position on Machining Performance. Okay, what is the MQL? MQL is the one of the cutting fluid that involved in any cutting operation for cooling the cutting tool and the surface of the workpiece by lubricating the tool workpiece interface and removing chips from the cutting zone. Okay, as we can see from the slide, MQL is used for CNC machining process and suitable for all the type, material and workpiece. What is the function of MQL? Function of MQL is to remove heat more rapidly. So overheating tools can increase the wear and tear exponentially, resulting into the dullness of the machine. This can lead to bending of the tool totally out of shape. So second one, reduce the friction and tool wear. Lubrication helps the tool cut more easily. This generates less heat and the friction and clear the chips away from the cut. So the last one, protect the tool wear from oxidization and the corrosion. Okay, why we use MQL? MQL is the most effective lubrication system on CNC milling machine lah. So the important is the maximizing efficiency of product, producing the highest quality finished product, decrease lubricant usage, increase machine tool lifetime, and fewer adverse health effect for the employees. So compare from the other conventional lubricant, MQL is one of the best lubrication system. We use carbon steel AISI 1045 as our workpiece material. Why? Because it's a good weldability, good machinability, high strength impact properties, and widely used for all industries. And lastly, comparing to other material, this steel is low cost and suitable for any type of machining. Okay, this is our problem statement. Conventional coolant failure to clear away dirt, material and other debris, which can result in inaccuracies in machining or even machine failure. So the second one is the negative environmental impact, which leads to safety and health issue among workers, especially in tool and mold industries. So the last one, it accounts 16 to 20% of the total cost of manufacturing only for coolant lubrication. Okay, this is our objective and project scope. Our objective is to investigate MQL nozzle position in MQL mist characteristic. So the second one is to study MQL on cutting performance and surface roughness of the workpiece. So the project scope is this research is focusing on effect cutting performance, surface roughness of workpiece on the output parameter when we change the position of the angle of MQL during machining process. Okay, this is our literature review. So, effect on the flank wear, Yan Lutao said on his research, Chinese Journal of Mechanical Engineer, the elevation of angle nozzle is an important factor which influence the growth of flank wear. By increasing the elevation angle, the growth rate is decreased. Okay, effect on surface roughness by TTK Dat on the Ho Chi Minh City University. He said on his journal, MQL may be considered to be an economical and environmentally compatible lubrication technique. Okay, next, as MOHD said on his Material and Manufacturing Process Journal, effect on tool wear, MQL system strongly reduce the roughness over that of the dry and continuous fluid machining by 35 and 12% respectively. Other than that, we got effect on cutting force. It said decrease the cutting force because consumption of lubricants in the MQL method is 7-fold less with the continuous lubrication. So this also decrease the risk of disease for the machine operator and the environmental pollution. Okay, this is our flowchart and variable. So we go to the start first, and then the selection of material, and then we go to the MQL position, divide by 2 process, distance nozzle from workpiece, angle of nozzle, and then we go to the character of MQL, divide by 2 process, flow rate and diameter, and we go to the milling process, and after that, after get the result, we take the data of the surface roughness, and the data we analyze, and then repeat on the different angle of the MQL nozzle, and then end the process. Okay, for our variable, we use carbon steel AISI 1045 as our workpiece. So the specimen size is the 100 mm times 100 mm times 30 mm. So the cutter size is 1 mm diameter. And then we go next to the important one. So we use the MQL as the lubricant. The angle nozzle is the 30 degree, 45 degree and 60 degree. So the nozzle distance from the workpiece, we use the 30 mm, 40 mm and 50 mm. Okay, before start machining, MQL device must be set up properly to CNC machine in order to require an accurate result of the tool wear and surface roughness. For the MQL system, the device is set up as we can see on this slide. The two hoses connected to a machine coolant and air pressure. The nozzle of MQL is attached near to spindle by magnet and set up 45 degree facing the cutting tool. The distance between insert and nozzle is 4 cm. The nozzle is directly facing the insert for high cooling efficiency. Then this is our table parameter setup for experiment. As we can see, we have 30 degree, 45 degree and 60 degree of nozzle angle. For the nozzle distance from workpiece, we have 30 mm, 40 mm and 50 mm. For the MQL flow rate, we have 0.66 milliliter per minute, 1.32 millimeter per minute, and lastly 1.98 milliliter per minute. Okay, this is our expected result. As we can see, the input is our fixed parameter, which is cutting speed and depth of cut. Then we continue to our process, milling process. After we get the output, we analyze the result on the cutting performance and the surface roughness of the workpiece. Then the variable parameter is what we change during the process, which is the angle of MQL nozzle and the nozzle distance from the workpiece. After that, we expect to get the graph angle MQL nozzle against the surface roughness and tool wear. So after that, we can analyzing the result on cutting performance and workpiece surface roughness. Okay, that's all from me. Thank you to my supervisor, Dr. Sanusi, because always support his student. And thank you also to my panel, Dr. Raja, Dr. Amran and Dr. Shukor. Thank you so much.